Okay, in this video, we'll focus on looking at the determinant of the matrix, of matrices. Now, previously we've looked at finding order, finding addition, subtraction, also multiplication of matrices. If that was clear, we can move to determinant. Now, determine, it means it's something that determines a matrix. That means if you've got the order, you can find the product of the major diagonal and the product of the minor diagonal, and the difference between the two gives you the determinant. So determinant is denoted by det, det, or sometimes they use bars like this. It means determinant is just equal to product of major diagonal element minus product of minor diagonal elements. But what do we mean by major diagonal and minor diagonal elements? I'll give an example of the matrix. If this is a matrix, the elements in this diagonal, let me even change the color, we call them major diagonal elements. The elements in here, we call them minor diagonal elements. So that's what we mean by major. Now, the product means you multiply these elements and those, then subtract. I'll give you a practical example. If I give you matrix A to be 3, 2, 1, 4, and matrix B to be equal to, no need for that. Then I say find the determinant of A. Now, for you to find the determinant of A, I will say that A is equal to 4 times 3. Which is these are major diagonal minus 2 times 1, which are minor diagonal elements. So this will be 12 minus 2 to give you 10. Follow the same steps that I'm showing. Step 1, do this. Step 2, do this. Step 3, do this. Don't just come to this step where you multiply things in your head without showing this step. Don't. Then you conclude that A is equal to that. So that's how you find the determinant. At this level, we only look at the determinant of a 2 by 2 matrix. They can't ask you to find the determinant of a 3 by 3 matrix, unfortunately, no. Or a 2 by 3, a 3 by 2, no. Here we consider a square matrix because a square matrix has got equal rows and columns. Let's look at another example. What if they give you, let's say, matrix A is equal to -4, 1, 5, and 6. How can you find the determinant? So proceed. Step 1. Det A is equal to -4 times 6 minus 5 times 1. And you will say -4 times 6 is -24. Take care of the signs. Minus 5 times 1, it's 5. From what we did yesterday on basic algebra, you'll be able to know that these are same signs, so we add and maintain the sign. This will be -29 as your determinant. Determinant can't just be a small number. It can be big, negative what? It's a determinant. Make sure you're doing the correct substitution, subtraction as well. Okay. Now, there are other practical examples of, for example, you've been given determinant. For example, if I give you that, given that matrix A is x, 2, 3, 5, and it has a determinant of 4. Find x. How can you do that? Now, we are just doing the opposite of what we've been doing. First, we know that the determinant of A will be equal to x times 5 minus 3 times 2. But this should be equal to 4 because we have been given determinant there. Now that we've been given determinant, we just to say equal to 4. Then we can find the missing x here. So say x times 5, that will be 5x minus 3 times 2 is 6, equal to 4. This will be equal to, let me use this, 5x will be equal to 4. This will go the other side, becomes plus 6. This will be 5x equal to what? 10 over 5 over 5. So x is equal to 2. How do you know that your answer is correct? Try to plug in a 2 there where there's x, so that you can have this. Then try to find the determinant if it will give you 4. This will be 10 minus 6, which is 4. So our answer is correct. Again, matrix A is equal to x minus 2. There's 3 here, there's 4, there's 1 here. And it has got determinant 7. Find x. We are doing the same thing. Determinant will be equal to 1 times x minus 2. But these, let's put them in small brackets like that. Minus 4 times 3. This will be equal to 7 like that. So 1 times x is x. 1 times negative 2 is negative 2. Minus 4 times 3 is 12, equal to 7. See 9. So now we are saying we got this because I multiplied 1 times this will still be the same. So I've got x. These are same signs I can add. This will give me negative 14 equal to 7. So x is equal to 7. This will go the other side, plus 14. So x will be equal to 21. That is the answer. So this is how you find the determinant. The last part is how to find the inverse. Then you'll be done with matrices. Now, the inverse of a matrix is just the inverse of the determinant times the cofactor of a matrix, or we call it the adjoint of a matrix. Now, step 1, for you to find the inverse of a matrix, you first have to find the determinant. Then step 2, find the adjoint. Then 3, multiply the determinant by the adjoint, then you'll be done. So let's look at an example. So example 1. If I've got this matrix, 2, 3, 1, 5. I tell you to say find inverse of A. Sometimes the inverse can be denoted by a to the power negative 1, m to the power negative 1, anything to the power negative 1, we call it an inverse. So sometimes they can't ask you to say find the inverse, they just say find a to the power negative 1. It's just the same as inverse. Now, how do we find the inverse? Okay, so how do we find the inverse of this matrix? So the first thing that we are going to do is, let's first find the determinant. Step 1, find the determinant. Determinant of A will be equal to 2 times 5 minus 3 times 1, which will be equal to 10 minus 3, which will be equal to 7. Now that the determinant has been found, let's go to find in the adjoint. What is the adjoint? With the adjoint, element in the major, by now you know which one is major and which one is minor. Element in the major diagonal, they swap each other. So 5 will go there, 2 come here. While elements in the minor diagonal, they change signs. This is positive, becomes negative 3. That is positive, becomes negative 1. This is what we call the adjoint of a matrix. Now, from here, Please don't forget to swap elements in the major and you change signs for each element in the minor. Then we are going to say inverse is equal to 1 over determinant is what? 7. We multiply by the matrix itself. This one. 2. And that's your inverse. If you want, you can multiply throughout. You leave it there, there's no problem. Matrix N is equal to 3, 2, 3, 4. Find inverse. Okay, so how can we find the inverse here? As usual, determinant first. Determinant will be 3 times 4 minus there 2 times 3. This will be 12 minus 6. This will give us what? 6. Step 2 is to find the adjoint. Should be equal to, we swap those elements. 4 goes there, 3 comes here. We change the signs, that becomes negative 2, that becomes negative 3. It's not always that they're going to give you positive and sometimes they can even give you negative, which you have to change to positive. Then 3, determine the inverse of n to the power negative 1 is equal to 1 over the determinant is 6 times 4, negative 3, negative 2, 3. You can multiply it throughout, there's no problem, which I'll answer from here. 1 over 6 times 4 is just 4 over 6. 1 over 6 times negative 3 just negative 3 over 6. 1 over 6 times negative 2 just negative 2 over 6. And 1 over 6 times 3 just 3 over 6. Which now can be simplified to 2 can go into 4, 2 times into 6, 3 times. 3 can go into 3, negative 1 into 6, 2 times. 2 can go into negative 2, negative 1 there, over 2 can go into 6, 3 times. 3 can go into 3, 1 into 6, 2 times. That is your inverse. If you know that this can be reduced like this, please multiply. Alright, we end here.